I was asked to do some problems from 7.2, so I'll be showing those to you right now. There are problems 19, 39, and 37. So I'll show you how to do that in this video for the benefit of everybody. Okay, so let me share the screen and show you what we have for those problems. Okay, 7.2, number 19, integral of t sine squared of t dt. So let's do integration by parts. Let u be t, and dv is the rest of the stuff, sine squared of t dt. And use the identity that sine squared of t is 1 minus cosine of 2t over 2. Differentiate this side, du equals dt. V is 1/2, I factor out the half, and then I integrate. Integral of 1 dt is t. Integral of negative cosine is negative sine 2t. And then by the chain rule, multiply that by 1/2. And remember that if I differentiate, I would multiply by 2. Since I'm integrating, multiply by 1/2. All right, so by formula, I is u times v. So u times v is 1/2 t times this stuff, t minus 1/2 sine of 2t, minus the integral of v du. There's a half, I'll take out the half. And then t minus 1/2 sine of 2t times dt. Distribute this, 1/2 t squared minus 1/4 sine of 2t minus 1/2. Integral of t is t squared over 2, and then minus 1/2 at the beginning. Integral of sine is negative cosine, so that sign becomes a positive. Cosine 2t, and once again by the chain rule, it's times another half. All right, so I have 1/2 t squared minus 1/4 sine of 2t, distribute here. I have minus 1/4 t squared minus 1/8. I have minus 1/2 times a half times a half, so minus 1/8 cosine of 2t plus c. And then finally, I can combine these two. 1/2 t squared minus 1/4 t squared is a 1/4 t squared. So 1/4 t squared, that's supposed to be a minus sign. Minus 1/4 sine of 2t minus 1/8 cosine of 2t plus c. Okay, problem 39, integral of cosecant of x dx. Okay, I showed you a derivation of the integral of the secant of x, and to do that, you multiply the top and the bottom by secant x tangent x. So the derivation for this one is similar. Integral of cosecant of x, you multiply top and bottom by cosecant x plus cotangent x. So this is 1. Distribute. The numerator is cosecant squared x plus cosecant x cotangent x dx. And it turns out the derivative of the bottom is almost the top except for a sign, sign. So let u be the denominator. U equals cosecant x plus cotangent x. Du is negative cosecant x cotangent x minus cosecant squared x dx, which happens to be the opposite of the numerator. Okay, so I multiply inside and outside by -1. So now -1 times all of this is indeed this, if you look very carefully. Negative cosecant x cotangent x, there it is, and minus cosecant squared x, there it is, and then dx. So I have a negative in front. All of this becomes du, and the bottom becomes u. So continuing up over here now, I is now negative integral of du over u. So that's negative ln absolute value of u plus c, which is negative ln absolute value of cosecant x plus cotangent x plus c. And I would accept that answer. Okay, if you're wondering how they got the answer in the back of the book, there's a lot more work to it. So this line means you can stop there, but how do you make it look like the back of the book? A property of logs is you can bring the negative up. So pretend that's a -1 up here. Ln absolute value of cosecant x plus cotangent x to the -1 power means reciprocal. So ln absolute value of 1 over cosecant x plus cotangent x. And then the trick is to multiply by cosecant x minus cotangent x over cosecant x minus cotangent x. Okay, so the numerator becomes cosecant x minus cotangent x. The bottom looks like a plus b, a minus b, so it's a squared minus b squared. So I have cosecant squared x minus cotangent squared x, and believe it or not, this thing here is equal to 1. So if I divide by 1, I can just ignore it. So final answer is ln absolute value of cosecant x minus cotangent of x plus c, which matches the back of the book. Again, a quick timeout here. Note, we have an identity from trig that 1 plus cotangent squared x equals cosecant squared x. So if I subtract cotangent x squared on both sides, I get 1 equals cosecant squared x minus cotangent squared x, which is what I have in the denominator there. All right, so that matches the back of the book. But once again, if you stop there, I would accept it. Okay, problem 37 was a pretty big one. It takes up a whole page for me to do the whole thing. Integral from pi over 4 to pi over 2 of cotangent to the fifth of phi. This funny looking thing that almost looks like the empty set. This is the Greek letter phi, sometimes phi, P-H-I. Cosecant cubed of phi d phi. Okay, there's several ways to do it. I thought I would change everything to sines and cosines since we're always comfortable with sines and cosines. So change everything to sine and cosine. So cotangent is cosine over sine. So cosine to the fifth of phi over sine to the fifth of phi. The reciprocal of the cosecant is the sine, so put sine cubed of phi on the bottom. So this does fall in the category of having an odd exponent, the so-called easier case when you have sines and cosines involved. Okay, so break up the cosine to the fifth to cosine to the fourth of phi times the cosine phi d phi, and the bottom becomes sine to the eighth of phi. That's a funny looking 8 there. So now I want all of this to only involve sine. This is already sine. This is cosine to the fourth. Okay, so think of cosine to the fourth as cosine squared squared. And we know we can change cosine squared to 1 minus sine squared. So 1 minus sine squared of phi squared over sine to the eighth of phi times cosine of phi d phi. Now I'm ready for a substitution. Let u equals sine of phi, du equals cosine of phi d phi. So that's going to be 1 minus u squared squared. That's going to be u to the eighth power. And cosine phi d phi is going to be du. What gets a little bit clumsy is to change this. Okay, pi over 4, plug in sine of pi over 4 is radical 2 over 2. Plug in pi over 2, sine of pi over 2 turns out to be 1. So 1's nice, radical 2 over 2 is not nice. So now I'm integrating from radical 2 over 2 to 1 of 1 minus u squared squared over u to the eighth du. Okay, so it's going to be quite clumsy. Multiply this out. 1 minus u squared squared is 1 minus 2u squared plus u to the fourth all over u to the eighth du. I want to use the power rule, so I change this to u to the minus 8 minus 2 u to the negative 6. That's u squared divided by u to the eighth is u to the negative 6. Plus u to the fourth over u to the eighth is u to the negative 4 du. To be continued up top. But this is going to be u to the negative 7 over negative 7 minus 2 u to the negative 5 over negative 5, and then plus u to the negative 3 over negative 3. Okay, from radical 2 over 2 to 1. Okay, rewrite this nicer. Negative 1 over 7 u to the 7th, double negative plus 2 over 5 u to the 5th, minus 1 over 3 u cubed. Okay, now a quick timeout right over here. Okay, radical 2 over 2 squared is equal to 2 over 4, which is 1/2. Okay, so radical 2 over 2 squared is a half. So we're going to keep that in mind as I plug this in. Okay, plugging in 1 is nice. Put a 1 there. 1 to the 7th is 1. 1 to the 5th is 1. 1 cubed is 1. So it's negative 1/7 plus 2/5 minus 1/3. Okay, now plug in radical 2 over 2 right here. So it's radical 2 over 2 to the 7th power. But every time I have radical 2 over 2 squared, I get a half. Okay? So I've got radical 2 over 2 squared times radical 2 over 2 squared times radical 2 over 2 squared times another radical 2 over 2. Okay? So every time I have a radical 2 over 2 squared, that's a half. I said it 3 times. So it's a half times a half times a half, which is 1/8, times an extra radical 2 over 2. Okay, same logic here. Radical 2 over 2 times 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 radical 2 over 2. Every time I have 2 of them, I got a half. So I have a half times a half, 1/4, times an extra radical 2 over 2. And then here, I got radical 2 over 2 times radical 2 over 2 times radical 2 over 2. 2 of them make a half, so 3 times a half times another radical 2 over 2. quite messy. Okay, common denominator here is 7 times 5 times 3, which is 105. So multiply this one by 5 times 3, or 15, negative 15. Multiply 5 by 7 times 3, which is 21. 2 times 21 is 42. Multiply 3 by 7 times 5, which is 35, and I get negative 35. Okay, now what am I doing over here? Okay, I've got a 16 in the denominator of a denominator. So if I multiply top and bottom by 16, these go away and the 16's on top. Likewise over here, I have a 4 times 2 in the denominator of a denominator. Multiply that by 8, multiply that by 8. That 8 will cancel these out. So I have 2 times 8, which is 16. Okay, here I have 4 in the denominator of a denominator. Multiply top and bottom by 4. The 4 cancels that out. And I have minus 4 over 3 radical 2. Okay, let's see. Negative 15 minus 50, minus 35 is negative 50. Add 42, and I have negative 8 over 105. So that's already done. I'm distributing the negative. So plus 16 over 7 radical 2, minus 16 over 5 radical 2, plus 4 over 3 radical 2. All right, I'm going to divide the top and the bottom of each of these by radical 2. So the radical 2 becomes on top, essentially. Okay, so that's gone, that's gone, that's gone. The reason is I want the denominator just to be 7, 5, and 3 so I can get to 105. Okay, so I have 16 over radical 2 minus 16 over radical 2 plus 4 over radical 2. Okay, and then I have 7 times 7, 5, and 3 right here. Okay, so again, divide top and bottom by radical 2 just to get rid of that. So it's in the numerator. All right, so multiply the 7 by 15 over 15. It'll give me a 105. So 16 times 15. Okay, multiply 5 by 7 times 3, which is 21. So 16 times 21, and that makes the denominator 105. And then multiply 3 by 7 times 5, which is 35. So 35 over 35, 4 times 35, and now they all have a 105. So I got the common denominator of 105 on both of these. So negative 8 over 105 plus all of this over 105. 16 times 15 is 240, minus 16 times 21 is 336, plus 4 times 35 is 140. Okay, if you combine these, it comes out to be 44 over radical 2. Okay, then rationalize by multiplying by radical 2 over radical 2. So the denominator is 2. 2 cancels to 44, giving me 22. So negative 8 plus 22 radical 2 over 105, or turn it around, you finally have what the back of the book has, 22 radical 2 minus 8 over 105. All right, so those are some of the problems from 7.2.